Pascal's triangle can be used for a number of applications. What we're going to be using it for is specifically with probabilities. In order to have Pascal's triangle, it starts out, there's a couple different patterns within it. First pattern that's pretty easy to pick up on is all the left and right diagonals of the triangle are ones. From there, there's a little bit more of a pattern, and we'll talk about that the further we go. So we start off with 1, 1, 1. So this is what we call the 0 row, the 1 row, the second row, and I'll show you how Pascal's triangle is formed. Again, I told you the diagonals are ones, but in order to get the next number in the middle, we combine those two diagonals that form it to get that next number. So if I want the third row, I know it's 1 and 1 on the outside. Well, 1 and 2 here give me 3. And I'm going to list that twice. So notice each time I'm adding another number into each row. So even though it's the third row, there are 4 numbers. So if we want the fourth row, again, diagonals, 1 and 1, I'm going to have 5 numbers. And that's okay. Even though it's the fourth row, I know it seems kind of goofy. And what you're looking for, the other thing you can know is that, well, the fourth row, it's 1, 4. So those will be the same there. Now, the other type of pattern that you will need to notice here is these, yes, you can add stuff to get your rows, but if I wanted like the 10th row, I'm going to have to list out Pascal's triangle a long ways if I want to keep going with this addition pattern. But you can use combinations in order to figure out that row. So for instance, if I want the 5th row, instead of adding them, we're going to double check to make sure that this method works. We want the 5th row. I'm going to do NCR. I'm going to go 0. That's going to give me the 1. 5 NCR1 is going to give me the next number. 5 NCR2, 5 NCR3, 5 NCR4, and 5 NCR5. These numbers are going to list out the 5th row of Pascal's triangle. Notice there are actually 6 numbers within that because we start at 0. I should have 6 numbers based on the 5th row of Pascal's triangle. If you use your calculator, 5 NCR1 or 5 NCR0 is 1. How many ways are there to select one item out of 5? That would be 5. 5 NCR2 is going to give us 10. 5 NCR3, type that in, it's also going to give us 10. 5 NCR4 is 5. 5 NCR5 is 1. Now, if you double check, that math does add up. So that's another unique pattern specific to Pascal's triangle. So far we've talked about the ones on the diagonals. They are adding in order to get to the next row, or you could use combinations. The other thing that you want to establish, or that would be somewhat of importance of a different pattern here, is the sum of each row. So if we look at row 0, the sum of that is 1. Row 1 is 2. Row 2 is 4. Row 3 is 8. Row 4 is 16. Row 5 is 32. So, 1, 2, 4, 8, 16, 32. What are we doing each time? Each time here, we are multiplying by 2. Again, there's a trick in order to figure this out. if you want the actual equation here, if you think about this, 2 to the 0 is 1. 2 to the first is 2. 2 to the second gives us that 4. 2 to the third gives us 8. 2 to the fourth gives us 16. So the row number that you're looking for is going to be your sum. So the sum of the row is 2 to the nth. N is determining which row number that you're looking for. So Pascal's triangle, it's using combinations. It has rows on the outside. You're adding if you really want to get the numbers in the middle. If you're not using combinations, the sum of each row follows the pattern of 2 to the nth power. And we'll work more with this on Pascal's triangle in terms of probability, but right now I just needed you to get familiar with what Pascal's triangle is and the different patterns that you can see within it.